Welcome guys. Considering this particular question, which is question number 1 of Mat362. So in this case, we have question number 1, which says that let x and y be two independent random variables having gamma densities. And then we all believe that the density function for and for a gamma distribution is given as thus: fx of x is always equals to 1 over gamma alpha, then multiplied by x raised power of alpha minus 1 e raised power minus x. So since we already believe that that is the gamma density function, so whatever we have to do now is we want to find the probability density function of u is equals to x plus y. So by the time you make use of convolution formula is given as thus, which is which is fu capital U of small u is always equals to integral of, for all x, you have to take the density function of x multiplied by the density function of what, y of y, then with respect to what, with respect to x. So this is the convolution formula. So one thing you have to take note now is that we are given u to be equals to x plus y. So in this case, if you make y the surrogate of the formula, you have u minus x is equals to y. So you have to substitute it into this place, whereby your y now is now in place of u minus x. So that is the reason why this formula here, this formula you're actually seeing here, is the range for all x, which is negative infinity to infinity. You have fx of x. Then this your fy of y. This y here now represents what? It represents u minus x in that case. So I hope that is clear now. So then after that, whatever you have to do now is to define what your fx of x is. Your fx of x is the gamma density function in terms of x, which is x is power of alpha minus 1, e is power minus x. So therefore you have 1 over gamma of alpha. In the case of fx of x, you make use of gamma of alpha. But in the case of fy of y, you make use of gamma of beta. Is that clear? So in that case, this is the gamma density function, which is x is power of alpha minus 1, e is power minus x. Now, the same thing goes for fy of y. Fy of y simply implies that you have y raised power of alpha minus 1. And y is no longer y. Y is now u minus x. So that is the reason why you have u minus x in this case. And then you have e raised power minus y. Instead of writing y in this place, you now have u minus x. So by the time you deal with these integrals, this is what you end up having. That is 1 over gamma of alpha and 1 over gamma of beta move outside from the integral, and then whatever you have left now is now 0 to infinity according to the limit for gamma density function. You have 0 to infinity, you have x alpha minus 1 in this case, you have this u minus x power beta minus 1 in this case. So this e raised power minus x times e raised power minus x times e raised power minus u minus x. So you know what that will give you. If you apply the rule of indices, we have minus u plus x. So this will cancel this. Whatever you have left now is now e minus u. So that is the reason why you have e minus u in this case. So you need to manipulate in this case. You need to manipulate. So in order for you to reduce this integral so that you can have a better definition, like in this case, we actually let t to be equals to x minus u. That is, let x represent ut. In this, okay, sorry, let me explain it clearly. When you look at this clearly now, you have u minus x, u minus x. If I let this x represent ut, so I'll be able to have something that is similar to better definition, which is 1 minus t, which is the form of 1 minus t raised power of something like that. Yeah. So in this case, if you make x represent ut, this 1 minus t will come outside. Do you understand that? And then you'll be left with u raised power of beta minus 1, right? And in this case also, whereby you have x is already ut. You have u raised power of alpha minus 1, then you have t raised power of alpha minus